that's not erasing. Okay, there we go. All right, so cofunctions are basically just mean getting one function in terms of another, like what's equivalent. And so if you think of graphing, you know, your typical sine function, you know, you kind of have that. And then a cosine function, you kind of have that. And if I just slide it over, if I just have a phase shift, I can get these guys to line up with each other. And so if you look up here, for example, and I take pi 2 minus u and set it equals 0, I get that. And so you can see that the phase shift is of 90 degrees between these. If you think in terms of the unit circle, that kind of makes sense also. So if I just draw a unit circle here, and you look at, say, 30 degrees, you get what? Square root of 3 over 2 and up a half, where over here you're over a half and up square root of 3 over 2. And so really it's like, okay, well, this would be what? The cosine of a, 30-degree angle. And then you're like, well, that's the same as the sine of a 60-degree angle. All right, and so that's what cofunctions are. It's just what angle for the other function would be equivalent. All right, so say I gave you sine of 20 degrees, and I really wanted you to figure out what that would be in terms of cosine. So kind of a fill in the blank, so to speak. All right, so if you look, you're going to use this formula right here. U would be your 20 degrees. So then over here, you would have pi over 2, which is 90 degrees in terms of degrees, minus that u. Right, and so I would just do a little subtraction. And so this is the cofunction. All right, I could do the same with trig. I'm sorry, the same with radians. So if I have this guy right here, and again, I want it in terms of cosine of something, I know the sine. So again, my u is this guy. So then I can take pi over 2 minus 5 pi over 12. And again, I could get a common denominator. So times 12. So I get cosine 6 pi minus 5 pi would be pi over 12. All right, and so again, this would be the cofunction with that. If I asked to get an exact value, I could mess with this a little bit, but it'd probably just be easier to go back here and use the sine of alpha plus beta. So if someone wanted an exact value, I probably wouldn't use cofunctions for that, but I could split it into what, 3 pi over 12 plus what, 2 pi over 12, and do sine of alpha plus beta. So I tend to not use cofunctions to find exact values because I'd probably go back to a different trig identity. Now, as far as proving these or verifying these, let me erase this and make some space. So if I ask you to verify one of these, if you kind of look at it, you can kind of guess what you're going to do. So the rule of thumb is once you know a trig identity, you can use that trig identity to prove other guys. So we'll just stick with cosine because that's what we've been doing here. And oh, looks like the order of this one is turned around a little bit, but that is okay because cosine is an even function, so it doesn't matter. But so in this one, if you think of this as cosine of alpha minus beta, then you're going to use that trig identity. So again, don't touch that, take the more complicated side. So again, there is no distributive property as far as with functions. You have to have an identity to get rid of that. I can distribute a function to other functions. I cannot distribute a function over input. So I look at this and I'm like, oh, okay, this is cosine alpha, cosine beta plus sine alpha, sine beta. And again, I don't expect you to memorize those. So what's my alpha? So I get cosine of x, cosine of pi over 12. And again, I use the subtraction one. So beta is just that guy right here because I use the subtraction trig identity. If you use addition, you have to add the opposite, and beta would actually be negative. So I have cosine that, and then over here I have sine of x and sine of, what is that, pi over 2. Okay. All right, and so then again, if you look at your unit circle at pi over 2, that's what, 0, 1. Okay, so I get cosine of x. My cosine value there is 0. And again, you don't want to skip any steps on these. You want to make sure I know that you know what's going on. Sine would be this guy. All right, and again, 0 times anything would be 0. And 1 isn't going to change it. So my final answer is sine of x. which is exactly what I wanted to verify. Oh, what happened? Seriously? Did I just lose that?
What?
I don't think it taped it. Ah! Seriously, I did such a good job. Oh, Andrew, I've never had that happen before.